So it's your chemistry class. And we are doing the chapter number 2. Chapter number two has 3 main parts: gases, liquids, and solids. We have done gaseous earlier. We have started the liquid portion. And today, what will we do? Let's see. Brief revision as usual. And today's topic is surface tension. All right. So we will be doing surface tension. What have we done? Diffusion. One of the characteristic property of liquids, same nature liquids can diffuse one another. They are called miscible, like uh, water and ink, or water or sugar syrup. They are diffusible. The rate of diffusion is slower than the rate of diffusion of gases. And what else? We have done compressibility. Since the molecules of a liquid are already very much compressed, very much close together, that is why they can't be compressed until we apply a great pressure. Expansion and contraction. Liquids expand on heating and contract on cooling. Right? Viscosity. This was done yesterday. What is viscosity? The rate of flowing of different liquids are different. Well, I told you the term rate means with respect to time. So different liquids need different time to flow. Suppose you have in one of the beaker or in one of the glass you have honey, in the second and the other one you have water, and you want to pour them simultaneously, then honey will take more time. So in science we say that honey is showing resistance, it's showing hindrance, it has barriers, right? That is why it is taking more time. So what is the definition over here of viscosity? The internal resistance to the flow of a liquid is called its viscosity. It is represented by neta. Viscometer is the instrument which is used to find out to the viscosity of a liquid. And what else we did yesterday? That viscosity, there are various factors which can change the viscosity, which can affect the viscosity. Like high temperature will reduce the viscosity. As I gave you an example of cooking oil, that cold normal the cooking oil at room temperature is quite thick, is quite viscous, having high viscosity. But when you heat it, then its viscosity will decrease. So by increasing the temperature, viscosity decreases, inversely proportional. By reducing the temperature, viscosity increases, right? And similarly, intermolecular forces, you also know when there is strong intermolecular force, then what? Then there would be more viscosity, directly proportional. So viscosity is directly proportional with the intermolecular forces. More intermolecular forces, more viscosity. Less intermolecular forces, less viscosity. And then the size of the molecule, the shape of the molecule, density, this all we have done yesterday. So what is today's topic? Trampoline. Right? The weight of this guy can only be balanced if the surface of the trampoline is being stretched, right? So what is the point over here? What is the point to be noted here is that the downward pull of a body, like the weight is acting downward, can be balanced by a stretched surface. Repeating, the downward pull, like weight of this guy, can be balanced by a stretched surface. Means A stressed surface can balance a force, a downward pull. This is the main point of this topic. Weight can be balanced by stretched surface, as you can see in this example. Okay, a paper pin, it is resting at the surface of the liquid, right? At the surface of the liquid, and it means its weight is being balanced by the surface of the liquid, right? Why? Why this is so happening over here? Because the surface is being stretched, so its weight, the weight of the clip, is being balanced by that stretched surface. But this force is not enough. We suppose we put some another object which is having more weight, then it will sink, right? So it means the stretched surface can hold some limited quantity, some limited value of weight. Like in this one, suppose if this on this trampoline, the weight of the boy is fine, the weight of a man is fine. But on this, suppose if we have suppose if we have a very huge animal like a camel or like an elephant, then what will happen? Then this stretched surface will demolish. It will be it will break. So same is true over here, that the weight of the paper clip, the paper pin, is being balanced by the stretched surface, but to a certain limit. Instead of paper clip, if we use a cap of a pen, then it will sink because the weight of the paper clip is greater, right? So what is the point over here? The stress surface is again balancing some weight, right? Now, from where this force has been developed, why the surface of a liquid is straight? What is the reason? Suppose you have some water in a glass, right? If there are million, billion, sextillion, zillion molecules of water in that glass, we can divide all the molecules into two categories. One, which are there in the bulk. Bulk means not at the surface. Bulk means not in the surface, just in the downward part, right? And the other molecule which are at the surface. So one of the molecule is being focused over here with the subheading in T. So we are focusing here a molecule which is at the bulk, the interior part of the liquid, right? And what can you see over here? This the central molecule is it is facing a section of the other molecules, right? The leftward, but all of these forces are balanced. The left side of molecule is balanced by the rightward one, the downward one is the upper one, and the other one is the other one. What is the bottom line here? The molecule which is here in the center, it experiences balanced forces. No unbalanced force is acting on it. No unbalanced force is acting on it, right? Whereas you can see the surface molecule. The surface molecule, there are four other molecules you can see over here. The left and right balanced, but there are two or in real life, in reality, it would be might be 20 millions. They are pushing the surface molecule downward. They are pushing the surface molecule downward, but there isn't any force acting on it to balance them in the upper side. That these two molecules are applying force on this central one, but there isn't any molecule over here to balance it. No molecule over here to balance it. Okay, this is being balanced by this one, by this one, balance force, right? Left side is balanced by right side, but the force, the downward pull of this one, the downward pull of this one, there isn't any molecule over at the top to balance them. No. So this molecule is facing, is experiencing some downward pull. Okay, right? So same is true for this one, same is true for this one, and the other ones, and the other ones, and the other one. So all the surface molecules are being experienced by, or rather, they are experiencing what? Unbalanced forces. I repeat, what is the main point over here? The surface molecules are balancing, are experiencing downward pull, which are not balanced by any other force, by any other top molecules. Okay. So to overcome this downward pull, the surface molecule develops a force among them. This force is called surface tension. This force is called the force at the surface of the liquid, like the stretched surface of trampoline provides weight to balance. Similarly, here the unbalanced downward pull can be balanced by stretching this surface, by due to the creation of a force among the surface molecule. Okay, repeating, the surface molecules are experiencing unbalanced downward pull. To balance this downward pull, they have stretched themselves. They become stressed surface. They have stressed surface. They have tensed surface. This tensed surface, the force at that tensed surface is called surface tension. Okay, so all the liquids have this surface tension because their surface molecules are being downward pulled, and to balance that downward pull, they stretch, they tense their surface. Okay, all the surface molecules. Same. See another one. This, these arrows, these arrows, these arrows, these arrows, these arrows are showing that these molecules are being tensed just to overcome the downward pull. Okay, see this one, the bulk molecule. See, all the forces are balanced. Left this, right this, and that. But here the surface molecules are being downward pulled. See this one. This is the surface molecule. Unbalanced forces are acting at the surface molecules. Balanced forces are acting over here. Okay. You can see another practical view that due to this stretched surface, certain weight like of this insect or the other one, they can sit over there. But instead of these insects, if a frog or something else is there, then they will go inside. So what is the definition of surface tension? We have seen that there is some force developed due to at the surface of the liquid due to the downward pull. So the definition of written is written over here. The force which stretches the surface of a liquid is called surface tension. Okay, it is represented by gamma, or another definition you can see in the there, the force in dynes acting upon a line of this is little bit technical, that how much force is acting. The force in dynes acting on a certain area like 1 centimeter on that of the liquid. What is the another definition according to the book? The force per unit length, how much force is being applied on a particular length, or how much energy is being at certain area. This is simply called surface tension. This is the reason. Just read it by yourself. Just told you that all the molecules in the liquid experience attractive forces from the neighboring molecules, fine. But the molecules at the surface of a liquid experience unbalanced forces as compared to the molecules in the bulk, in its body, in its bulk. As a result of this inward pull, the surface of the liquid behaves as a stretched membrane, causing surface tension. Okay? SI unit is Newton per meter. What is the definition? Force per length. So what is the unit of force? Newton. What is the unit of length? Meter. That Newton meter. Or in terms of energy, joules per meter square. What are the other units? If you take force in dynes and length in centimeter, then dynes per centimeter. Similarly, the unit of energy in British engineering system is ERG. So it's written ERG per centimeter square. So if you think logically, then it will be easier for you to understand, to memorize their units. Force per unit length, Newton per meter. Force per unit length, Newton per meter. Or if you are taking British engineering system, then dynes per centimeter. What is the unit of energy? Joules. What is the definition? Energy per unit area. Joule per meter square or erg per centimeter square. Which instrument do we use to find out the surface tension? This instrument. This is the instrument which is used, which is known as stalagmometer. What? Stalagmometer. How can you find viscosity? By viscometer. How can you find surface tension? By stalagmometer. And the last slide, again, the same logic. Surface tension depends on certain factors. If you increase the temperature, surface tension decreases. Increase the temperature will result less force of attraction. When the force of attraction is less, surface tension decreases. And secondly, it depends on molecular structure of the liquid. As surface tension depends on intermolecular forces, therefore liquid in which the hydrogen bond formation takes place will have more surface tension. Hydrogen bond means an extra bond, an extra attraction. When there is a hydrogen bond, when the structure has some hydrogen bond, then it has more surface tension. So water has more surface tension because its hydrogen bond, extra bond, has more value than rest of its other liquids like petrol or etc. Okay. So what is next? We'll see in the next class. What will you see? We will continue with this topic. We will see the effects of surface tension. That what are those topics? Capillary action in a little way, and due to surface tension, the area of a body reduces. These will be the two topics. And what else? That's all. Okay, take care.